Okay, this is a review of our review guide for chapter 12, which is matrices. So, to start off with, what is element A sub 2, 3 in matrix A? Okay, what this number right here is telling you is it's telling you which row and which column is the element in. So it is in row 2 and then column 3. And the intersection of those two is the 4. So the answer to this problem is 4. All right. Which element is in row 1, column 2, and that answer is 5. Okay, simplify. We are adding or subtracting. The main thing that you got to remember when you add or subtract matrices is that they have to have the same dimensions. If they do not have the same dimensions, then you cannot add or subtract them. So that again means dimensions means they have to have exactly the same number of rows and columns. And when you do, you're just going to combine the corresponding elements. So when I look at this problem, first row, first column, okay, negative 2 minus negative 1 is negative 1. Okay, 2 minus 3 is negative 1. 0 minus negative 9 is positive 9. Negative 5 minus negative 2 is like negative 5 plus 2, so that's negative 3. 5 minus 4 is 1, and 9 minus 7 is 2. So let's go ahead and do another one, and then I'll talk to you or give you some advice about these problems because they're easy. A lot of this stuff I think everybody thinks it's easy, but it's just also easy to make a careless mistake. So again, negative 2 minus a negative 1 is negative 1. Positive 2 minus 3 is negative 1. 0 minus 9 is negative 9. Negative 5 minus negative 4 is negative 1. 9 minus 4 is 5. So again, I'm just combining the corresponding elements. And 9 minus 7 is negative 2. So that's our answer. On these problems, even in the next one that I'm fixing to do, it's easy to make a mistake. I think most of y'all, what you're going to miss is just careless. So hopefully at the end of the test, you'll come back and cover up the answer on your test and then redo it and make sure that you get the same answer each time. Okay. For my limited space, I'm going to try to write on top of this, okay, so you can see. So negative 4 times this matrix, maybe I can write it right here. Let's do that. So this is going to be negative 4 times that matrix. So negative 4 times 3, negative 4 times 5, negative 4 times negative 1, negative 4 times negative 5, negative 4 times 4, and negative 4 times 8. So this is the matrix that I get when I have negative 4 times A, negative 4 being my scalar. And now I'm just going to add those two together. So when I add them together, I'm going to get 12 plus 7, 20 plus negative, nope, wrong one. I'm going to cross it out so I don't add the wrong thing. So that was 12 plus 7, 20 minus 2. You will be sure to have plenty of room on the test to write this, so you won't have to worry about that. 4 plus negative 5 is negative 1. 20 plus negative 7 is 13. Negative 16 plus negative 1 is negative 17. And 8 plus negative 8. Oh, y'all, I didn't multiply that. Okay, I'm sorry if you've been watching that far going, she's an idiot. Okay, but I checked it. Negative 4 times 8, this should be negative 32. And negative 32 and negative 8 give us negative 40. Okay? So that one's fixed. Somebody will probably tell me, keep watching, persevere. All right, so this next one, actually, let me box this so you'll know that this is the final answer to that problem. And then when I do this one, now this is optional on how you want to do this, okay? I prefer, if I'm going to do A minus 7B, then I'm going to take a negative 7 and put it through here. So if I put negative 7 and then I just have to add the elements, and that just helps me because I make fewer mistakes when I'm adding than when I'm subtracting. So negative 7 times 7 is negative 49. Negative 7 times 4 is negative 28. I'm doing it this way, y'all, but if you want to put through a 7 and then subtract, you will get the same answer. Once again, the beauty of math. You can do it more than one way, and we all get the same answer. Negative 7 times 1 is negative 7. Negative 7 times 1 is just negative 7. Negative 7 times negative 4, and I get the same thing again. So, tried to make some of that multiplying easier. Okay, so I'm going to go ahead and write the answer over here and box it so you will be able to see. So now, because I distributed the negative 7, I'm adding, and I'm going to cross this out so I don't add the wrong thing. Okay, so negative 7 and negative 49 give me negative 55. 7 and negative 28 give me negative 21. Negative 7 plus negative 7 is negative 14. Negative 2 plus negative 7 is negative 9. And 6 plus 28 is 34. And 8 plus 28 is 36. So that's the answer that we have for number 6. Okay, solve the matrix equation. Um, I'm going to pause for 1 second and I will be right back with you. Okay, so picking back up to solve this matrix equation, so that I can show all the steps, because I told people I would show them all the steps, I'm going to take these two problems, hopefully this works okay, to another page. And there they are, except we got some crazy lines through them. Alright, but hopefully y'all can go past that. Alright, so this first one, x plus 5 times a matrix equals another matrix. So I'm going to distribute that scalar. So we have 5 times 2, 5 times 8, negative 8, 5 times negative 4, and 5 times 2. So x plus this matrix equals this, because I didn't do anything over here. And so how am I going to solve that? That's like x plus a number equals another number. So hopefully you realize to get this to the other side, I'm going to have to do the opposite of that. So I'm going to subtract. So x equals 4, negative 6, 2, negative 8. And I'm going to subtract this matrix. 10, negative 40, negative 20, and 10. So my final answer will be 4 minus 10, which is negative 6. Um, negative 6 minus a negative 40 is negative 6 plus 40, which is 34. 2 minus negative 20 is 22. And negative 8 minus 10 is negative 18. So this is the answer to number 7. All right, so if you look at number 8, okay, I don't know if y'all noticed, but these are the exact same numbers as that one, okay? If it wasn't, okay, you would solve it the same way and get down to it, okay? So you get down to, this time though, it's negative 2x is equal to this negative 634, okay? Because everything about the first part of solving it is exactly the same. So what am I going to do now is I'm going to divide everything by negative 2 or multiply by negative 1/2, however you want to think about it, okay? But I'm going to go divide each of these answers by negative 2. So negative 6 divided by negative 2, 34 divided by negative 2, 22 divided by negative 2, and negative 18 divided by negative 2. So that's the answer that I have for 11. Okay, but it's the exact same problem as this one over here, y'all. The only thing different is this negative 2. So you can carry it down. But you're going to do it the same way. All right, so continuing on back, let's go back and do number 9. Number 9, so we are multiplying. Find the product means to multiply. And when you multiply, you have to do rows by columns. Okay? And we've talked about this. This is a 2 by 2. This is a 2 by 2. These numbers have to be the same, and my answer will be whatever the outside numbers are. So my answer is going to be a 2 by 2. And this is the first row, first column. So I'm going to multiply first row. Let's try like this. First row, first column. So that's negative 4 plus 0. 1 times negative 4 is negative 4. 0 times 5. So negative 4 plus 0 is negative 4. And I'm going to go here, and that's going to be first row, second column. So 1 times negative 6 is negative 6, plus 0 is negative 6. And then I'm going to go to second row, first column, which is this right here. So 4 times negative 4 is negative 16. Negative 16 plus 25 is 9. And then I'm going to do second row, second column. So that's negative 24 plus 30, and that of course gives me 6. So there's my answer right there. So I hope the color code can help you figure out or remind you on how to do those. All right, another 2 by 2. So this one's going to start off, I'm going to a 2 by 2 and a 2 by 2. So, you know, if I'm giving you square matrices, those are always going to come up to that same dimension. Okay, so starting off, first row, first column. So negative 20 plus 35. Okay, then I have first row, second column. So 20 plus 7 is 27. Then I have second row, first column. 5 minus 35 is negative 30. And then I have, um, this is second row and second column. So negative 1 times 5, negative 5 plus negative 7, which is negative 12. So there's our answer for that one. Okay, and again, to check your work, y'all, go write the problem down on some scratch paper and do it again. Make sure that you get the same answer when you do it twice, and that's good enough to help you know um, how you've done. Okay, number 11, again a 2 by 2. So I'm starting off first row, first column. So 6 times 3 is 18. 18 plus 48, 66. Then I have first row, second column, and that's 30 plus 42, which is 72. Then I have second row, first column, negative 18, negative 72. That's negative 90. Can't read that 9 very well. Negative 90. And then you have second row, second column, and that's negative 30 minus 63, which is negative 93. So sorry about the tight quarters here. But that's what we got there. Okay? All right. What is the area of a triangle? Okay, the area of the triangle is to take 1/2 the determinant, and you're writing these. 5, negative 3, negative 2, 2, negative 4, 2. And then you have ones for your last column. Now, remember to calculate this, we have to repeat these rows. So that's 5, excuse me, repeat the first two columns. 5, negative 2, negative 4, negative 3, 2, and 2. And now I'm going to go calculate. So let's go with my downhill products, and I'm going to show you how you do it without a highlighter. That's 1. Those 3 numbers come next, and then those 3 numbers. So 5 times 2 times 1 is 10. Negative 3, 1, and negative 4 when I multiply give me 12. And then 1 times negative 2 times 2 is, and I write plus a negative 4, so that helps me remember that I'm supposed to be adding those products. Okay, now going uphill, I have negative 4, 2, and 1, and then I have 2, 1, and 5, and then I have 1, negative 2, and negative 3. So the first one is negative 4, 2, and 1, that's negative 8. And then I have 2 times 1 times 5, which is 10. And then 1 times negative 2 times negative 3, which is positive 6. So if I combine these two, then I'm going to have, remember it's always downhill minus uphill. So my downhill products give me 22 minus 4, which is 18, but this is 1/2 absolute value of 18 minus, add those together give me 8. And 18 minus 8 is 10, and half of 10 is 5. And area is always square units, so it's going to be 5 square units. All right, let's look at the next one. Same thing, so I've got 1/2, writing them down, negative 4, negative 1, negative 2, negative 5, negative 3, negative 1. And then you have a bunch of ones. And then I'm going to copy those rows, so that's negative 4, negative 2, negative 3. Copy those columns. I don't know why I always keep saying rows. Those are columns. Negative 5 and negative 1. So my downhill products are going to be that first diagonal, which is negative 4, negative 5, and 1. And then I'm going to have 1, negative 1, 1, and negative 3. And then I'm going to have 1, negative 2, and negative 1. That looks pretty bad. Um, let's go ahead and do that. So that's positive 20, and then positive 3, and then positive 2. So those are my downhill products. So let's go with the uphill. We have negative 3, negative 5, and 1. I have negative 1, 1, and negative 4. And then I have 1, negative 2, and negative 1. So the first one, negative 3, negative 5, and 1 is 15. Negative 1, 1, and negative 4 is positive 4. And 1, negative 2, and negative 2 is positive 2. So when I combine these two, again, downhill minus uphill, then I have 1/2 the absolute value of the downhill products, the sum of the downhill, minus the sum of the uphill. So 25 minus 21 is 4, and 1/2 of 4 is 2. So we have 2 square units for that. Okay, does the matrix have an inverse? Okay, this question, y'all, you're answering the question is yes or no. That's what you're going to put. Now, how do you find that out? You have to go figure out what the determinant is. Okay, so what is the determinant of this? This is 1 minus 0. 1 minus 0 equals 1. So the answer to this question is yes, it does have an inverse. The only one that doesn't have an inverse is if the determinant is 0. Now, once I do that, a 1 means I don't have to worry about it, but it's really just so that you can know and refer back to it. To find the inverse, it's 1 over the determinant. So it's this number here, whatever you get here goes on the bottom. So 1 over the determinant, and then you're writing that matrix. You switch these two numbers, and you negate these two. So if you had a number here, you would have to multiply it through. You don't leave it like that. But this is what it looks like. Actually, that should be not those determinant symbols, but that. So the answer would be one, yes, and this is the inverse right here. Okay, so second one, does it have an inverse? I've got to find the determinant first. 0 times negative 3 minus 0 times 45, that's 0. Because the determinant is 0, the answer is no. So make sure that you have work on your paper showing me why it's not yes, or why the answer is no. Okay? All right, moving on to, that's the ones we already did. All right, matrices A and B, are they inverses? Okay, the way we have talked about doing that is for you to show me what is A times B. So actually, let me move over a little bit. You can come over here. So A times B is equal to, it's a 2 by 2 and a 2 by 2. So multiply it out. I have, actually, and let me show you that. So A times B is 21 minus 20 is the first one because we're going to get a 2 by 2. So I'll go ahead and write it like this. Okay. The next one is first row, second column. So that's 30 minus 30. And then you have negative 14 plus 14. And then I have negative 20 plus 21. And this equals 1001. Okay? But I'm not done yet because I have to go show what B times A equals. So B times A equals, again, 2 by 2, but I'm showing it out just so that you can follow and make sure you know how to do the problem. B times A. Now to do B times A, I need to write A next to it because I can't do it the other way. So negative 3, 10, 2, negative 7. So negative, that's 21 minus 20. And then I have negative 70 plus 70. And then I have 6 plus negative 6. And then I have negative 20 plus 21. So that shows me that when I combine those or simplify all those sums, then that's what I get. So, are they inverses? The answer to our problem is yes, they are. How did I justify my answer? By doing this right here. Okay? Now, the other method I talked about in some of your classes, if you want to tell me the inverses, you can go take one of them and calculate the inverse, but you got to show me all the steps of how to calculate the inverse if that's what you want to do. Okay, evaluate the determinant. We did this on the previous page, but we will do it again. So you have to copy those first two columns, negative 5, 0, negative 2, 1, 3, and 3. So my downhill products, again, I'm underlining because I don't have might not have a highlighter on the test. Okay? Some people mess up because they don't have that highlighter. Sorry, my lines aren't so straight. So negative 5 times 3 times negative 2 is going to be 30. And then you have 1 times 3 times negative 2. And that, of course, equals negative 6. 6 times 0 times 3 is 0. Now for my uphill products, I have those numbers, and then I have those three numbers. So I'm making sure that I'm underlining the three numbers. So negative 2 times 3 times 6 is going to be negative 36. 3 times 3 times negative 5 is negative 45. Negative 2 times 0 times 1 is 0. This is 445. Okay? So when I combine these two, okay, this is just straight out calculating that determinant. Then to find the determinant of any of these matrices, we're doing the downhill minus the uphill. So my downhill products I write down at the bottom. So 30 plus negative 6 is 24, minus my uphill product, which is negative 81. Did I get that right? Yep, negative 81. And so when I combine those two, I get an answer of 105. Okay, look at the next one. We have, again, copy the columns. 3, 5, 1, 5, 2, negative 2. Okay, we're going to have to pause. Okay, so our fire drill is over, and I'm going to continue with the determinant of this 3 by 3. So I've repeated the first two columns, and now I'm going to go find my downhill products. Okay, so this is the Three numbers for my first downhill. That's the second one, and that's the third one. And my uphill products will be these numbers. Boom, boom, boom. And so then I'll go write what those are. So 3 times 2 times 4 is 24. 5 times 1 times 1 is 5. 15 times -2 is -30. And then my uphill products, 1 times 2 times 3, -2 times 1 times 3 is -6, and 5 times 4 times 5 is 100. So that gives my downhill products 24 plus 5 is 29 minus 30 is -1. The 6's cancel minus my uphill products of 100 gives me an answer of -101. Okay, moving on. Again, still downhill minus uphill. So my downhill product is -7 and -7, which is 49. My uphill product is -5 times 6. So let me do this. This is my downhill product. This is my uphill product. So that's 49 minus -30, which gives me an answer of 79. Okay, moving to the last evaluation of a determinant. I have my downhill product is -7 times 4, which is -28. My uphill product is 4 times -3, and it's minus that. So -28 minus a -12 gives me a final answer of -16. Okay, just straight calculation. What is the determinant? Okay, now what is the solution to the system? Solve using inverse matrices. So again, let's see if I can do a better job of copying and taking this to a new page. And I will do these um, on another screen. Let's see how that looks. That looks better than the first one. Okay, so um, number 21. To solve the solution, and we're supposed to solve using inverse matrices. So when I do this problem, um, we start off by writing the coefficient matrix. The coefficient of these is 1, 2, 1, 1. That's your coefficient matrix. Okay, the variables that I have in this problem are x and y, and the constants that I have are 9 and 1. Okay, so from there, we've talked about, when we first talked about solving, that means that that matrix xy equals the inverse of the matrix on that same side of the equation with the variable matrix. So I write that notation, and then I write my constant matrix. So now I'm going to calculate this. So it's 1 over the determinant, which is 1 minus 2. And then I switch these two, and then I negate these two, or take the opposite of them, whatever they are, and then I multiply this. Or, excuse me, I keep that the same. Now I'm going to multiply, because one of the things we talked about when we do this is to multiply these two first. So 1 over 1 minus 2 is going to be -1. Then I'm going to calculate this, and I'm going to just do it out so that I don't make any mistakes. This is going to be, this is a 2 by 2 and a 2 by 1, so I'm going to end up with a 2 by 1. So 1 times 9 is 9, plus -2 is 7. -9 plus 1 is -8. So when I distribute that through, then of course the matrix that I get is -7, +8. But as I've mentioned before, this is just a method of solving. So the correct way to write your answer when you have a system of equations, because this is a line and a line, and they intersect at a point. So the answer to my problem is going to be written as an ordered pair, -7, 8. All right, so we'll go do the next one. Again, first off, I'm writing the coefficient matrix. So that's -3, 2, negative 4, 3. That's the bell for lunch, but I'm going to keep going. X times y, x and y, excuse me, equals the constant matrix of 10, 1. Okay, so we're going to write that matrix xy equals the inverse of this, and I write it because I don't want you to try to do too much in one step. So I have to take the inverse of this coefficient matrix times the constant matrix, and in our next step we're going to go calculate. That's 1 over, to find the inverse, we take 1 over, and that's negative 9 minus a negative 8. I'm going to write it like that so that people can see and know where we get our numbers. Then I switch these two, so that's going to be 3 and negative 3, and I negate these two, which means give them the opposite sign. So now I have 10, 1. So negative 9 plus 8 is again negative 1, so we have that negative 1 going through here again. 30 minus 2 is 28, and 40 minus 3 is 37. So when I take that through, I end up with negative 28 and positive 37. So when I write that ordered pair, it's going to be negative 28 and positive 37. Okay, so back to our page, because that was too much to try to fit in there at one spot. But what I can do is I can go ahead and write what those answers were. This one was negative 7, 8, so it doesn't look like that we didn't do those problems. And this one was negative 28, negative 37. Okay, so now write the system as a matrix equation and identify the coefficient matrix. So I'm going to write the coefficient matrix in purple. I'm going to write the variable matrix in pink, and I'm going to write the constant matrix in orange. So what does that look like? Okay, so my coefficients, whether you want to go down or across, doesn't matter. I'll go down. So that's my coefficient of A's is 9, negative 3, negative 5. Negative for B's, it's negative 3, 1, and 4. For C's, it's 5, 6, and 3. So that is my coefficient matrix. Next is my variable matrix, and hopefully you can see the variables in this matrix are A, B, and C, and they have to be written in a column. And then my constant matrix is what's on the other side, and that's negative A, 5, and negative 5. So keep in mind, the only thing that may be challenging is making sure that all of the things are in the right order. You've got to have all the same variables lined up to be able to transfer it to the matrix. Okay? So, all right, what's the solution to the matrix equation? Same thing we've just been doing, so I am going to, again, copy it to another page so we have more room to do it. And you'll see it's the same thing that I've been doing. Okay, so first off, now just like we did before, okay, when we're doing these, we're going to say that this matrix X is equal to the inverse of this times that. So, like I've asked you, I want you to write that. And so that's to the negative 1 times negative 3, 0, negative 7, 1. So, that gives me, how do I calculate? That's going to be 1 over 9 minus 8, because I'm calculating the inverse of that. And you know what? Before I did that in a different color, let me do that so it'll be easy for you to see where that's coming from. So my inverse is 1 over 9 minus 8. And that's, then I switch these two and negate these. Okay, and then I multiply by that matrix that was on the other side. So that's negative 3, 0, negative 7, and 1. So when you look back at it, you'll know that this is the calculation of that inverse. Okay, so to continue, 1 over 1 means whatever I'm going to get is going to be my answer, and a 2 by 2 times a 2 by 2 is a 2 by 2. So negative 3 plus 28 is 25. Then I'm doing first row, second column. So that's 0 plus -4, so that's -4. Then I have 6 minus 63, or 6 plus -63. That is -57. And then 0 plus 9 is 9. And this is a matrix equation. It started off as a matrix equation, so your answer is going to be a matrix equation. All right, so 25. Well, that was kind of weird. Okay, so that equals the inverse of this matrix, inverse times the matrix that's on the other side. And again, remember the order of these is very important because we've talked about how multiplication of matrices is not commutative. So this is 1 over -27 minus a -26. And I switch these two, and I negate this diagonal. So that's, and then I'm going to multiply it by uh, the matrix that I had on the other side. So that gives me -27 plus 26 is going to be -1. So we're going to have -1, and I'm going to multiply these two. So this is -24 plus -39. That gives me -76. Positive 16 plus 36 is 52. And when I carry my determinant through, then that gives me an answer of positive 76 and -52. All right, 3 problems left. Got to go back to our page, and I'll put those answers in back at the end. Okay, so another one, writing the system as a matrix equation. So when you write this as a matrix equation, again, you got to make sure all the x's are lined up and all the y's and all the z's. So this might be easier to go across. And you look at this and say, I don't have an x, and if I don't have an x, I got to put a 0. But my y coefficient is 4, and my z coefficient is -9. So I'm going to the second row. My x is 3. My y is -2. I don't have a z, so it's 0. And then the last one, x coefficient is 5. There is no y, and the z coefficient is -3. So I'm going to multiply those by x, y, z. That's my variable matrix. And I get my constant matrix, which is 6, 4, 0. All right, these last 2 problems are on the calculator, graphing calculator. They'll be on your graphing calculator portion of your test. If you don't, you need to come see me if you don't know how to use your graphing calculator. But what I'm going to show you is the minimal amount of work that I want you to show me when you do these problems. So this first one, if you want to say my variable matrix of x, y, z is equal to, actually, let's go ahead and write it out like we're supposed to. That's too much to do in one step. So let's do this. Let's write our coefficient matrix, which is -1, -4, -1, 2, -1, -3, and then -4, -5, and 1. And I'm going to multiply that by my variable matrix, x, y, z, and that equals my constant matrix, which is 15, 3, and 23. So what I'm asking you to write on your paper for me, come down just a little bit, is you know that you're supposed to multiply by the inverse of this. So what I want to see is that x, y, z. All right, and use your calculator to put that to the -1, and then write what you get for that inverse. And then, so that means this is going to be, when I did it on my calculator, you're going to get 8/5. You're going to have -9/10. You're going to have -11/10. Then I'm going to have -1, negative, oh, it's not negative 1/2, it's just positive 1/2. Positive 1/2 and positive 1/2. And then the last row is 7/5 times negative 11/10 times negative 9/10. So you're showing me that this is this matrix inverted, okay? So that's what your calculator gave you, and then you write this one down, and you're going to get an answer. My answer is not written in a matrix because I didn't start off with a matrix equation. And the answer to this problem is -4, -2, -3. And I tried to tell you in class and emphasize it's easy to plug these numbers back in here and just check it. So 4 plus 8 is 12, and 12 plus 3 is 15. So we know that that problem worked. Okay, so this last problem, when I write my coefficient matrix, that's going to be 2, 2, there is no z, so I'm going to have a 0. Then -1, 2, -3, and then 3, 0, and 4. And so that gives me, that of course is x, y, and z. And that gives me 4, 4, and 2. Because that's my constant matrix. So I'm going to write my variable matrix, and then you're going to give me what the inverse of that coefficient matrix is using your calculator. So you should have for this one 4/3, -4/3, -1, -5/6, 4/5, or is that 4/3? Actually, that's 4/3. Not bad. Uh, come on. 4/3 and 1, and then it's -1, 1, and 1. So that's the inverse of my coefficient matrix. And when I multiply that by my constant matrix, then I'm going to get my answer, which is -2, 4, and 2. And again, easy to check. If I plugged in here, that would be -4 plus 8, and that equals 4. And you can continue for the other three. But that's how you can know. Check it. If you have any questions, please come see me.